Hello, and welcome back to the Antony Holding YouTube channel. Today we're going to be calculating the quark structure of a jar of mayonnaise with a nice Minecraft background, because me reading my notes out wouldn't be very interesting. Here's the background. So, welcome. Thank you for watching, first of all. And the first part of calculating the quark structure of any given substance is calculating the atomic structure of any given substance. Now, the atomic structure and therefore the quark structure will vary depending on the recipe you went for, or if you're me and you just googled atomic structure of mayonnaise, you might have got something along the lines of H3CO plus HO3 plus H3CO plus NPO3C3H9 is what the amalgamation amalgamates to make mayonnaise. So I totaled that to 1N, 1 nitrogen, 1P, 1 phosphorus, 8O, 8 oxygen, 15 hydrogen, and 5 carbon. And those are the one particle of mayonnaise, one atom of mayonnaise, well, not one atom, because one particle of mayonnaise, that is what goes into one particle of mayonnaise. And then I took their atomic numbers, no, atomic mass, not atomic numbers, that's very important, atomic numbers, mass. And I got nitrogen as atomic weight, atomic mass. So nitrogen's atomic mass 14, phosphorus 31, oxygen is oxygen 16, by times it by the amount of oxygen I had, which was 8, and I got 128. Hydrogen 1, I had 15 hydrogen, so I times it by 15, and I got 15. And carbon 5. Carbon 12, but I had 5 carbon, so I times it 12 by 5 and got 60. Now the reason we do this is to total that to get the total atomic mass of one particle of mayonnaise. And once you've got that total atomic mass, which is 258 daltons, you can calculate how many daltons there would be in a gram. And I used an online calculator. I don't expect you guys to know the conversion rate. You just search daltons to grams. I'm trying to work out 200 grams of mayonnaise. So you whack in 200 grams and it tells you how many daltons that was. Now for me, that was a long number, suffice it to say. Over 1,235,658,404. Oh, I read it wrong. Let me do that again. We'll just pretend I didn't say that last bit. 2,365 billion. Nah, I've plugged it up again. It's a bloody 12-digit number. Right. Let me just take a second. Hope you're enjoying the Minecraft gameplay. So that's right. 235,658,449,800 daltons is how many is in 200 grams. And so to get a multiplier for our numbers, I divided that by our original number 248 and got 950,235,685 rounded up, because it was 0.5 and you always round up in physics. Equals E. I've called it E to act as our multiplier for the equation. The next stage was totaling the amounts of protons, neutrons and electrons from our earlier nitrogen, phosphorus, oxygen, hydrogen. Now the structure of nitrogen is 777, so 7 protons, 7 neutrons, 7 electrons. And the structure of phosphorus is 15, 16, 15. 15 protons, 16 neutrons, 15 electrons. Oxygen is 888, that's 8 of everything. Hydrogen is 1 proton, no neutrons and 1 electron. And carbon is 6 of everything. So first we did the protons and we totaled it. 7 from nitrogen, 15 from phosphorus, 64 from oxygen, because you've got to remember to times that 8 by the amount of oxygen we have, which is 8, so 8 squared is 64. 15 from hydrogen, doing the same thing, 1 times 5, and 30 from carbon, because we had to do 5 times 6, and that totals 131. So you write that down, protons 131. And with neutrons, we're fortunate enough that we've got one extra neutron. Neutron? Yeah, neutron. We've got one extra neutron in phosphorus, but we've got one less in hydrogen, and everything else is the same. So it is the same number, because 1 minus 1 is nothing, so there's no change. And then it's the exact same for electrons, because electrons and protons mirror each other. That's how atoms become stable. So protons 131, neutrons 131, electrons 131. So that is the proton structure of one particle of mayonnaise. Now we need to make that into down and up quarks and anti-up quarks, I believe. So proton, the quark structure of a proton is up, up, down, and that's where they get their positive charge from, because protons have up quarks have a plus 2/3 positive charge. So if you add 2 of them, you get a plus 1 1/3 positive charge. But down quarks have a minus 1/3 positive charge, so it just cancels their other third out, and it's a plus 1 charge. That's how you know it's a proton. And so you might be able to guess what the quark structure of a neutron is. It's down, down, up. So that means there is a down quark minus 1/3, another down quark minus 2/3, plus quark, up quark, takes you back to 0, which is the charge of your neutron, which is convenient. I believe these are hadrons because they have 3 quarks. And then this tricky one, electron, is a lepton, which is made up of up quarks and down, or an up quark and an anti-up quark. No, it's a quark and an anti-quark, not an up quark and an anti-quark. And the quark structure of an electron is one anti-up quark and a down quark. So anti-up quark means everything is times by -1. So the charge of plus 2/3 goes to a charge of minus 2/3. So then you total minus 2/3 from the anti-up quark and minus 1/3 from the down quark, and you get a -1 charge, which is what you have for your electrons. That is a fairly simple way of working it out if you are that way inclined. So, with that all being said, you times the 131 protons by 2 to get the amount of up quarks in the protons, and then you can also add the 131 up quarks from the neutrons, and you get 393. For the down quarks, there's 131 in the protons, because you don't have to times that. Neutrons, you have to times it by 2, because there is that multiplier of there being 2 down quarks per neutron, and that's 262. And then electron is just a linear 131. You total that, you'll get 524, I believe. Probably should have checked that, but it's fine, I'm sure it's right. And then for your anti-up quarks, it is just 131 from the electrons, due to them only being in the electrons, and there's only 1 per electron, so it's the same number as the amount of electrons we had in the first place. So you times that by our multiplier of 950,235,685, and you get, for your up quarks, there is, it's another long number, we're going to need to take a minute. I believe that's 363,442,624,200, which is a fuckload. Down quarks is 497,923,498,900, and your anti-up quarks is 124,480,887. 124,480,875. 124,480,875 874,700, which is also known as a fucking mouthful. I'm gonna have to bleep that. So yeah, that is your the quark structure of mayonnaise. 300. Let's call it 373 billion up quarks, 498 billion down quarks, and 124 billion anti-up quarks. And you know, that's a lot of mayonnaise smeared across a half pipe. Thanks for watching. What the fuck is mayonnaise?